Here's another example we can work. Suppose a sample of 400 people is used to perform a taste test. If the true proportion of the population that prefers Pepsi is 0.5, what is the probability that less than 44% of the persons in the sample will prefer Pepsi? So let's take a look here. Again, it's a probability question. Note that, as most of our problem questions have been in Unit 2. And I want to next sort of catalog all the information that's in this paragraph. So the first thing I read over is that there is a sample of 400. And it also mentions that the true population proportion that prefer Pepsi is 0.5. So I guess we're going to say our success is Pepsi. And P is equal. That's our population proportion, 0.5. Great. Now, if P is 0.5, Q is 0.5, right? So half prefer Pepsi, half of the population prefer something other than Pepsi. Okay, what is the probability that less than 44% of the persons in the sample will prefer Pepsi? So that last bit of information in the last sentence, that 44% is P hat, because it says 44% of the persons in the sample. P hat is a sample proportion. And if you don't mind, I'm just going to write it as a number between 0 and 1 because that's how my software will want it a little later in the video. All right. So what we're doing here is we're answering a question and we're trying to figure out the probability that less than 44%. So what this works into for us is a sampling distribution of proportions. How do I know that? Well, I always notice that I'm doing this when I see a probability request has the two-sidedness here of Pepsi or not Pepsi. And instead of asking for the number of successes that we would observe, they put the percentage or proportion of successes. So for me, it's easiest to solve this with the sampling distribution of proportions. Now, what I need to do is I need to compute the standard deviation for this. And it looks like N times P over Q. Oops. I got those mixed up. Hold on. Sorry about that. Let me erase. That is P times Q over N. I knew it the minute I wrote that did not seem right. All right, let's plug in what we know. P is 0.5, as is Q. That's a times here. I'll make that one a little bit bigger. And it's going to be over 400. So personally, I'm going to need a calculator to do this so I can get a value for the standard deviation. So I'm going to go to Rguroo. And right there, the last option, applets and calculators. We have a Desmos calculator that's in here. Going to grab scientific. Zoom in so it's easier to see. Here we are. So in my mind, if you can type it, write it first, which we did, and then type it, Desmos does a lot of the order of operations for you. So we're going to grab the square root first because it was on the outside. And then over here on the right, there's this a over b, which will just simply make a fraction form there. And then we can type p, multiply it times q. And in the denominator, we put our sample size. Great. So there is our standard deviation. It's 0.025. So this is equal to 0.025. Great. So we're going to head over to our normal calculator to solve this. We also have, let's see, one thing to note is that we're going to need a mean. So they write the mean this way, just reminding us it's the mean of a sampling distribution of proportions, and that's always equal to p, which in our case is 0.5. All right, you might want to take a screenshot of this one to keep all this information with you. And then we're going to head over to Rguroo. All right, let's close out the calculator, and we're going to go to probability simulation. Click on probability, grab the calculators, go to continuous. So it's set at the normal model by default. And so now we're going to put the 0.5 here. That was P, 0.5, 0.025 was our standard deviation. We had to hand calculate that. It said less than, so below 0.44, and that's for the 44% they asked about. So double check that everything's set the right way, and we'll click preview, and we get our probability. It's quite small for that to happen. It's 0.00819, etc. So 0.008 if we're rounding to 3 decimal places. So really small. Let's take a look at the picture. And you can see here, it's almost off the curve here. It's quite far away from the half that was our mean. And so that little tiny yellow region corresponds to the very, very small probability we found here with Rguroo. Hope this was helpful.